let's take a look at how this works. Example 4. It says, given the functions f of x equals 3x over 4 minus 2x, and g of x equals square root of x, h of x equals just x, and m of x equals 2. Those are what we're given. So A says find the domain of g plus h of x and evaluate g plus h of 4. So let's take a look. We first need to know, let's go ahead and write this, g plus h of 4. Let's find g plus h of x. Well, we know that that's going to be equal to g of x plus h of x. Okay? So that's equal to, go up here to our g, square root of x plus h of x is x. So that's what I get. What is the domain? Let's look at that. Do we have any restrictions? I don't have an x or a variable in the denominator, but I do have one under a square root. So that I know square root of x has to be greater than or equal to 0. So x has to be greater than or equal to 0. So that is a domain restriction, is that x must be greater than or equal to 0. So the domain is the set of all x such that x is greater than or equal to 0. Okay? So now we want to find g plus h of 4. So let's go back to what we got right here. We know it's going to be equal to square root of 4 plus 4. I just took out each of those x's and put in the 4. So that gives me 2 plus 4, or g plus h of 4 is equal to 6. And is that greater than or equal to 0? Yes, so we're good. Let's look at B. It says find the domain of h minus m of x and then evaluate h minus m of negative 3. All right, h minus m of x is equal to h of x minus m of x. Go back up here. H of x is x. M of x is just 2. So h minus m of x is equal to just x minus 2. So is there a domain restriction? Well, no, there's not a variable in the denominator, and there's no variable under a radical. So the domain is all real numbers, or negative infinity to infinity. So h minus m of negative 3 would be x minus 2, and we're going to take out that x and put in a negative 3. So h minus m of negative 3, take out the x, put in a negative 3, and then minus 2. So it's equal to negative 5. And we have it. Alright, let's look at C. It says find the domain of f times h of x and then evaluate f times h of negative 1. Alright, f times h of x is equal to fx times h of x. Now let's look at f of x. That's 3x over 4 minus 2x times h of x is just x. So how do we simplify that? Well, we're going to put that over a 1, and we're going to just multiply. So that would give me 3x squared in my numerator and 4 minus 2x in my denominator. And that's f times h of x. Now, let's see if there are domain restrictions. Yes, there are, because I have a variable in the denominator. So what we know is, for that restriction, we know that 4 minus 2x cannot be 0. So subtract a 4 from both sides, and we get negative 2x cannot be negative 4 divide by -2, and I get x cannot be 2. So what is the domain? It's everything else. The set of all x such that x isn't 2. And there's your domain. Now let's go over here and find f times h of -1. Well, we just found that it was equal to 3x squared over 4 minus 2x. So now we're going to take out the x and put in a -1. 3 times -1 squared over 4 minus 2 times -1. That's equal to 3, -1 squared is 1 over 4 plus 2, or 3 over 6, which is just 1/2. Finally, we have D, and it says find the domain of G over F of X, and then evaluate G over F of 9. Okay, so this is going to be equal to G of X over F of X. So that's equal to, let's go back up to the top again, to where we have our functions. G of X is square root of X over F of X is 3x over 4 minus 2x. And now we have a complex fraction. But because it's a single fraction over a single fraction, I can rewrite it as square root of x divided by 3x over 4 minus 2x. And then we're going to keep change flip to simplify. So we keep square root of x over 1 times flip to the reciprocal of that divisor. And now you're like, okay, but what do I do with that? Well, what I'm going to do is I'm going to distribute this to each piece here. So that's going to give me 4 times square root of x. Now multiply that, and it's going to give me minus 2x square root of x all over 3x. And you can't cross cancel anything. So let's see what kind of domain restrictions we have, because this one is kind of complicated. So first off, we know that 3x cannot be 0. So x can't be 0. But we also know, if we go back to here, this one had its own domain restriction, and that was 4 minus 2x can't be 0. We already did that one in the last problem. So we know there x can't be 2. So that is the other restriction. So we've got 2 restrictions. So what is the domain? The domain is the set of all x such that x doesn't equal 0 or 2. So that one was a little complicated. You got to remember when you set these up, like at this step, if there is a variable in a restricted position, you've got to include that domain restriction also along with what you get for your final answer. All right, let's find G over F of 9. Let's go back to what we got. This is what we got. It's kind of complicated, but that's what we got. 4 radical x minus 2x radical x all over 3x. Now we're going to plug in a 9. So it's going to be 4 square roots of 9 minus 2 times 9 square root of 9 all over 3 times 9. All right, that's a 3. So we've got 12 minus, this is a 3. So 2 times 9 times 3, or 3 times 2 times 9, however you want to think of it. So it's 12 minus 54 over 27, which gives you negative 42 over 27. Simplify by dividing by 3, and you get negative 14 ninths. Harder. It says for a summary of functions and function notation, see your textbook. And then there are problems at the bottom for you to work.